Cool. So good morning all. Welcome to this session. In this session, we are going through a Hadoop Submarine project. This is a new sub-project in the Hadoop community, pretty much focusing only on the running deep learning workloads on top of Yarn and Kubernetes, or in fact, any compute platform. So we will have some demos in this just to give you a feeling that how easily you can use the Submarine. So here we are. So my name is Sunil Govindan. I'm an Apache PMC and a committer for Hadoop community. I'm working in Hadoop from 2012 onwards, pretty much on the Yarn resource management platform. Recently, I'm pretty much looking into the hybrid compute environment, which includes Yarn, Kubernetes, and almost all the resource management platforms. So I work at Cloudera as staff engineer, and this is my colleague Sankun. Over to you.
Okay, so morning everyone, and my name is Zhang Kun, and mainly working on Hadoop Yarn, and I joined Cloudera maybe about more than half a year ago, and before that I worked for Intel for about 7 years, mainly working on the Hadoop and Spark optimization and contribution for the open source community, and now I'm focusing on the hybrid computation platform recently. Yeah, so. Okay.
Cool. Yeah, thanks. So here's the agenda for today. Pretty much like we will give a brief about why did we initiate the Hadoop Submarine project, what are the reasons and what are the goals behind that, and also we'll give you a brief introduction about what Submarine can offer with a quick set of demos. And we'll also introduce to the Hadoop Submarine ecosystem, because Hadoop Submarine alone will not solve all the problems. So there is an ecosystem surrounding Submarine, including notebooks and etc. So we'll give a brief demo and overlook to that. And finally, we'll wrap up with current status of the Submarine community and the future outlook, how it's going to be. So let me just start. See, there are a few pain points for any ML engineer and data scientist, right? The core ML code, what they are writing, it is basically only a very small part of the whole journey of the ML lifecycle, because there's always a hidden work they'll be continuously doing to do the infrastructure management, the machine resource management, and also on the other side, how to collect the data, where the data resides, and how to pipeline the data to the training, and also the configuration tuning and etc. So in the ML lifecycle, the whole set of data or stuff they do, that is a normal data engineer who is doing, it is too much of work. And instead of, he should really concentrate only on the core ML code, where actually the model development and training has to happen. So that is actually the pain point it's already an ML engineer facing. If you look in detail, I'm just trying to categorize in such a way that there is storage, that is Amazon S3 and HDFS, where today's most of the data, which is already processed, is actually placed. And the data engineering, which is actually your Spark job or Hive or any ETL jobs, which actually process the data and ingest to the cloud or HDFS. That data need to be fed to the for the data science jobs, right? And which to do the model management, development, and training and serving, etc. So there are two different worlds here. One world of data scientists who actually develop the models, and another world where the data resides and how the data is ingested, ETL jobs, etc. So what Hadoop Submarine is actually offering is basically a cross-platform solution to integrate these two worlds together. It bridges the gap, and there is no solution as of now exists. And this actually can help a lot, because today's most of the data is in the Hadoop clusters, and there are no big offer at this point of time there to run these data science jobs easily. And it can run on top of compute platforms such as Yarn and Kubernetes, which makes the life of the data scientist even more easier. So let me give a much more detail about where we started the whole journey with. So an HDFS is basically the adapted storage at this point of time in the big data world, and Yarn is basically one of the best orchestration engine for the big data workload specifically, because it has a core scheduler which can actually create more than 3,000 to 4,000 containers per second for the batch jobs like Spark or Hive or MapReduce maybe. So if you want that kind of number of workers to be launched, this is one of the best scheduler to churn out that much of scheduler containers to run the jobs. And it also has the integration Docker. So it gives it avoids a lot of complexity in the environments. And it has integration at the first class level to the GPU and FPGA. by which, of course, the data scientists will be running all their jobs on the GPUs itself because it can run more faster. So already GPU and FPGA support is already there, and with the introduction of topology scheduling in Yarn very recently, we were able to improve the speed of the whole GPU by more than 3x in best case scenario. And we have support of native services to run some long-running jobs as well. So coming to the data engineering world, like we are already having tight integration with these ecosystems such as Spark, Hives, Flink, and a lot of other ETL jobs. And with this, this ecosystem will help to drive ingest the data for the ETL jobs and put the data to HDFS or cloud. So at this point of time, you can see that almost all the data, most of the data is actually in the HDFS layer or in cloud layer. And you're already having a cluster maybe on a Hadoop-based Hadoop 2 or Hadoop 3-based cluster, which is actually doing this job. Now to run your ML or DL jobs, part of what you guys will be trying to do, customers are doing is basically create another cluster, maybe running some other TensorFlow there, and try to pipeline the data from the storage and etc. like that. But that's not needed because with the introduction of Submarine, you can run the same jobs on top of the same very cluster which you're already using for running ETL jobs. So that's one of the clear advantages at this point of time here. So I'll go to the details of what Submarine can offer actually with this context what I said. So it can run an ML job very simply. And it is something like if you have ever experienced Distributor Shell. So Distributor Shell is an application on Yarn, so by which you can use a simple command line with specify the jar name and just give a set of parameters and it can start the job. Now, Submarine also can do the same thing in a similar way. Simply point out the jar name of the Submarine and give a set of command line option, and you will be able to run the job. So it supports TensorFlow and PyTorch at this point of time. You can specify the type and a set of configurations, such as like worker related configuration, parameter server related configuration, etc. And I know there's a bunch of CLIs here, so in easy ways, move to a YAML file. So everything you want to put here, put it to a YAML file and load it out. So it's another easy option to start the job without specifying much of the complex parameters. And you can also run a TensorBot. So TensorBot is basically a one-point path, a UI, wherein which you can see you can track your normal jobs what you submit to the cluster, and you can see the errors and all the mappings what you want to do. You can monitor via the TensorBot. So Submarine can simply can launch a TensorBot as a long-term running service, and all the jobs that you're running, it can be tracked through the same TensorBot with a small click. And coming to the ecosystem. So as I mentioned earlier, Submarine alone actually is a simple jar file which wraps the whole two worlds together, and it also needs a tight ecosystem because the data scientists today, they're pretty much comfortable in working with notebooks like Jupyter or Zeppelin, etc. So Submarine is already integrated with Zeppelin. By using a simple Zeppelin notebook, which has a Submarine interpreter, one can actually submit the jobs, track the jobs, and manage it, and use a dashboard to see the whole view, etc. So no need to use CLI there. It's even more easier with this tight integration. And it also has an integration with Azkaban, kind of a scheduler, so that you can do batch scheduling one by one. And Submarine can now run on top of Kubernetes as well. So similar to the same, what you get the same experience on running on top of Yarn, you'll get the same experience to run Submarine on top of Kubernetes cluster. By pointing to the data point, maybe HDFS or S3, you will be able to fetch the data and run on top of Kubernetes, and only change is specify a parameter called Submarine runtime class to Kubernetes, and the job will be running. So there are some active works in progress, and some are very close to complete. So one is basically the runtime called Tony, which is developed by LinkedIn. So Tony is called TensorFlow on Yarn. So this active development of Tony has happened from last 1 to 2 years by LinkedIn. They are leading it, and it has been already open sourced in the GitHub of LinkedIn. And this is already used by many of the customers in various organizations as well. And with that, you will be able to run the TensorFlow on Yarn without much complexity. And now Submarine actually has an integration with Tony. So using the same Submarine CLI, you can actually use the Tony runtime on Yarn. So with this, what helps is basically we have support of Hadoop too. Means like you can run the Submarine on Hadoop too. If you are old cluster, then still and there's no Docker, still Submarine can run on top of that by using this Tony runtime. Now some more active developments are happening on the model management and serving, such as CRUD, deploy and serving. This is pretty much an active development which is very close to complete in the community. So this is a quick overlook of what we are offering already and what we are planning to do in the upcoming future. So let's go to a deep dive demo, wherein which a few of the things what I mentioned, we'll try to show you the quick demo. Over to Sankan for that.
Okay, thanks Sunil for the great introduction. So in the demo, I will play some recording and for the first two core features of Submarine, which is running on Yarn and Kubernetes. And so let's first see the, OK, so this is a Yarn 3, Hadoop 3 Yarn new web UI with the GPU resource. You can see that each node has the GPU card. And you can see the NVIDIA GPU information here. And then now, it's the command line. So that's the basic feature. You type in the number of workers, number of perimeter servers. This is a distributed training here. And with the GPU resource, memory, vCore declaration, and your training command in the. So I can give you just a high-level idea. I won't go into detail here. So let's run the job. OK, so Submarine is running. And then the training on GPU is quite fast. So and then you can check the TensorFlow job in the Yarn Web UI. You can see that the TensorFlow job and TensorBoard together running with the job serving there. OK, so worker, parameter server, and also you can click the quick link of the TensorBoard from the Yarn Web UI to see your training loss, your training accuracy. OK. And you can see also the network graph here. Okay, and then this is the Hadoop Submarine running on Yarn in the container. And moving on, let's see that how Submarine can run on Kubernetes. Okay. So this is a Kubernetes cluster. And also similarly, here we use the engineer way, that's use the command line. And then same interface, similar with the command line we just issued for Yarn. OK, so Submarine now running. And then after the job finished, we can see that in the Kubernetes web UI, you have the pod of the TensorFlow job running. OK, a worker and a master. So this is a single node training job. And also, Kubernetes supports these services and the ingress concept, which you can get the access point of the TensorBoard easily. And here we print out the endpoint and the stand output. OK, so copy it and paste it in the browser, and you can see that the TensorBoard is waiting there. OK, great. And then that's the very basic of Submarine. You can using CLI to run it against your Kubernetes and Yarn cluster. And then moving on to the what data scientists are like. They use the Zeppelin notebook usually, and then don't like the command line. And then we provided the Submarine interpreter integration in a notebook for the data engineer and data scientist to use. Okay. So generally, the notebook enabled with Submarine interpreter will have three features. You can type the %sign submarine.shell to enable the shell command to play around in the container, and also the Python used to write Python code, and also you can enable the dashboard in the notebook to manage your job, which is submitting job and see the logs, and also access the TensorBoard and also the Yarn history UI. Okay, so let's see details. So this is a high-level picture. You have the Hadoop cluster, and the user maybe is doing some experiments locally in a container with the deep learning environment, Python pre-installed there, and you have the data maybe in the container, and you do the experiment, and then you can later submit this job without code change to the Hadoop cluster. So, okay. Let's take a first look at the Submarine interpreter. So when a user opens a notebook with Submarine interpreter enabled, the Yarn will automatically launch a Submarine interpreter there. Okay. So this is a managed notebook example. So you can see that we create a node with Submarine interpreter. Yarn will automatically create an interpreter container. So you can see that the container is running here. So the data scientist and data engineer working here to do some experiments. Okay, and moving on, let's see that the Submarine interpreter feature one by one. So you can imagine that the data scientist would check something in the container in his integrated development environment, which is a web version. Okay, and in this notebook, you can type in the %sign submarine.sh to wake up the shell into the container. And then here I will show the example that I'm listing the file in this container a little small. Okay, so ls/ and it will pump up the data in the container. Okay, so that's the data set in the container. Okay, and then you can write some other nodes in another paragraph with the data you found in this container, and also in the next you can write some Python code. This is a neural network training example. And running it will show the training process which has a precedent. And also you can use the Python code to visualize your model loss. Okay, so moving on, you can also do some fancy thing, which maybe create a digital input panel and then use your mouse to draw some number. Maybe let's see that. I'll draw a number 4 in the panel, and we have the binary data of the number. And so this is the fancy experiment that we are doing in the notebook. Okay, so paste the data here, and also run this paragraph. Okay, and then we can show the handwrite number I just draw. Okay, then, and we have the model, and when we predict it locally, and it would be 4. Okay. So let's say experiment generally. Yeah. And we have the code ready now. And then for the data scientist, we have the dashboard enable the user to submit this job. We just, or maybe we have the code already and want to train with a larger data set. And then we go ahead to submit this job into the Hadoop cluster, and the interpreter will have this ability to help you to do this. So all you need is use the dashboard. Okay. Okay, let's get an idea of this. So this is the CFR10 example in the TensorFlow standard example. You have many Python script nodes here. And okay, so similarly to the other Submarine interpreter feature, you add a paragraph and you issue the %, and then not shell, not Python, just type in dashboard. Then you can wake up the dashboard in this notebook. Okay, so you can see that it's here. So, okay, this is a dashboard, very straightforward, and has the some button there for you to quickly access the TensorBoard, or maybe print you some usage of the Submarine. Single node command line, but I think data scientists won't click this button. Okay, then and the distributed training command line, and also it's showing the usage of each parameter here. Okay, and then let's get back to the dashboard. You can see that from the from the Dropbox, there are several items that you can click, which is a job run, job stop, and some other actions you can choose. Okay, and then moving on, let's submit our job through this dashboard. You only need to input the data and also the command line that you use to running the training script. And from the dashboard, you can see that we paste the command line here, and you can just choose the name of the nodes like locally. Okay, and then run this job. You can see that the Submarine is running against Yarn, and it will later show that Yarn will accept this job. Okay, and you can see the log in the same page. Okay, so the job is running, and you can check the log. And also, it will show that the interpreter used the command line, which is shown here, to submit your nodes together, doing some dirty thing, and but to the data scientist, it's submitted to the Yarn cluster and running. Okay, and also you can click here to jump to the Yarn's UI to see that this job is running there. Okay, and this is how we submit the job in the in the Submarine interpreter's dashboard. And also, we can check the job status in the same place. Here we try to kill the job while it's running. So we use the Docker stop to kill that container. And you'll see that in the dashboard, it will show the status of the Yarn job. Okay. And moving on, we'd like to see the dashboard and which show the TensorBoard from TensorFlow. And also, we can go directly to that in this dashboard. Okay. Okay, so that's pretty much the demo today for this Submarine ecosystem and the core features of it. So Submarine can run across platform and have a very convenient notebook which the data scientist and the engineer likes. So, okay, so moving on, Sunil, okay.
Yeah, thanks, Angan.
Yeah.
Cool. So let's look into the present and future. Where are we now? The current status of the project, and where are actually we heading to? Before moving on here, so as I earlier mentioned in the whole job, like, so if you have a Hadoop 2 or a Hadoop 3 cluster, and you don't need to literally upgrade your cluster to some latest version or create another cluster parallelly to run the TensorFlow or the PyTorch kind of a data science jobs, you can use the same very cluster what you use today for ETL jobs or any type of jobs you are running, and simply use Hadoop Submarine jar files to run this TensorFlow or PyTorch for the model processing and development and etc. So that is one of the core advantage of having Submarine, and that's also one of the reason why for a faster release cadence, we moved Submarine out of the normal Hadoop release pipeline. So the first version of Hadoop Submarine actually got released along with Apache Hadoop 3.2.0. So after that, what we have done is we moved Hadoop Submarine as a sub-project of Hadoop with a separate release cadence. That means we can do the releases faster, and it need not have to be in line with Hadoop ongoing releases. This is similar to Hadoop Ozone, which is actually another sub-project in the Hadoop community. On that line, so now Submarine actually releases 0.1.0 along with the 3.2, and in this particular version, we are actually many of the customers today are already started using Submarine. I think we'll give a couple of case studies later to showcase what are the real use cases at which the customers are already using it. And with this particular focusing only on the Submarine as a sub-community in Hadoop, we are actually able to build up a good community who are only interested in the data science, right? So you don't necessarily need to be a Hadoop expert to do development for Submarine. So it's a pretty focused community which has weekly calls or bi-weekly calls, and we have updated all the related data details about that in the wiki, so that if you are interested to contribute to the Submarine, you will most welcome to come and contribute. Cool. So that is where we are now, and so where are we going? So we are planning for a 0.2.0 release in upcoming weeks, wherein which one of the core features will be the Kubernetes runtime, what we have mentioned. It's already integrated, it is merged to the trunk. We are actually doing the release cycle just to release out to the community. And the LinkedIn Stony is actually one of the core feature. It will be coming in 0.2.0, and the PyTorch integration along with TensorFlow and the Kubernetes, and some of the hyperparameter tuning, which is actually makes it more easier for the user to use Submarine, like a job.yaml file, as I mentioned, instead of CLI. You can simply use a YAML file to load a set of configuration parameters and start the Submarine job with ease. And for the model serving, we made it even more easier. So a bunch of improvements are coming in the 2.20 version. So I'm just going to a case study here. This is a company called NetEase. They're one of the largest online game company in China. So this is actually their real use case, what they are today doing. They have around 6 Hadoop clusters, almost around 6,500 nodes, and they are running more than 100K jobs per day. Mostly it's all Spark jobs. And along with the same cluster, they are running now the ML jobs as well. So they didn't need to create a separate cluster just to run ML jobs and do some management of the data pipeline, data input, data output, etc. So they are using the very same cluster which they have today to run the same ML jobs, and they are running actually it's in a Kubernetes cluster, but they already have it in the as part of the core one, and all the data is actually coming from the HDFS side. So actually just giving a bit brief here that when they did this actually experiment with Kubernetes, they found that most of the resources actually what is there were actually getting wasted a lot with the Kubernetes one, because most of the time these ML jobs may be idle and the cluster was never utilized to the potential, and the maintenance cost was very difficult for them to run both one. So this is just a brief about why they moved to the Submarine from the typical Kubernetes model cluster, and they are actually verified with us on a 200 node GPU cluster, and that has become a success in the past 2 months back, and they are already started moving or moved almost most of the ML jobs to the today's Hadoop clusters. So that's actually about the NetEase, how they actually brought up the whole story there. Moving to the community side of the whole project, so we have a separate website here, which is hadoop.apache.org and Submarine. So if you go over there, you'll get a very brief about what is the community, what they're doing today, and what are the documents related to the projects and the contributors, and all the details what you want to there, it will be there. And we have some weekly sync-up calls happening. That doc has the schedule of the calls, and you're most happy to join and provide more use cases for a better community development. The whole source code sits inside the same Hadoop repo as a sub-project, so any code in the trunk, it will be there in the repo. You can actually go over and check that. And some of the core companies who are actually contributing to the Hadoop Submarine is basically Cloudera from our end, and NetEase from China, LinkedIn, Alibaba, Didi is again a company in China, and Huawei. So these are some of the companies who are actually making a lot of development to the Submarine to make it as of today, and working on towards a better adding more features to Submarine. And many of the customers already started using it. So it's about a quick brief about where are we now and how are we actually focusing on. Yeah, so that's pretty much it from our end. So we are pretty much open for questions if you have.
Yeah, please.
Yes. First of all, I would like to know whether it is already implemented in HTTP, or will it be implemented at some point?
So at this point of time, I'll take the question. So the question was, is it already a part of the HTTP release or not? So in HTTP, we have released 3.1 in the previous cycles, and this is not as part of the HTTP at this point of time. But going forward, we already announced the plan of CDP as a common Unity project of Cloudera, and so we are just taking a call whether to include it in whichever the release line which is needed. So we'll update the details about that in which release Submarine will be part of that. And because we also have projects like CDSW, which is actually Cloudera Data Science Workbench. So along with that also you may be able to experience that. So we'll give a lot of clarity in the upcoming months once we get a final say on that.
And another question: when you get to really serving a model,
Yeah.
how will security be met? Security issues like authorization, authentication.
Okay, so on the other side, like if you know HTTP, right, we already have something called Nox as a gateway server. So yeah, every access, right? So you have the external gateways like Nox, and so all the things will be there in place when you serve it. But if you look at only Submarine as a core project, it does not offer you anything. So when it runs along with Nox and other kind of whole ecosystem, then yeah, it will be secure. But as alone, it's just an independent piece. Yeah.
So what changes did you introduce to improve utilization on Yarn for NetEase's use case?
Okay, so So Yarn actually is quite famous in terms of because of the way that the better SLA, right? So Yarn has the better SLA because of the queuing. You can have hierarchical queuing, and you can define the capacity for each of the sub queues and etc. So the queue at which that this particular workloads like ML workloads running, and so what we have done is basically Yarn has some other feature called node labels as well. So those nodes which are actually running ML will be categorized to one node label, same GPU. And that GPU node label is associated with one of the sub queue, and you provide the percentage there, how much percentage of the capacity is needed to configure for that label. Now, if you run the job on that particular queue, we are effectively able to utilize the whole queue, that set of resources for the ML jobs. And also we are sharing the same particular set of nodes to another queues, and based on the max capacity, it can simply take it. So it's the inbuilt mechanism of Yarn, wherein which based on the queues, you are able to utilize the cluster much better. Yeah.
Oh.
If I get it correctly, then I will be able to create a model through machine learning with Submarine. Then how can I utilize them? Or is there any support, or how does it look like?
I didn't get the last part of the question.
So how does it look like if I created a model with Submarine?
Okay.
How can I use that? How can I utilize them?
So one of the ways is Zeppelin, right? So you can actually, so you can do the whole development, like you can write the Python script which are needed for your model, and then use Submarine, the Zeppelin interpreter. We have for Submarine, you will be able to run that particular set of codes by using the interpreter. It can do the validations. So yeah, so you can.
I mean the serving?
Yeah, serving part. Right, so this is actually, so you can actually, oh, not that one. Yeah, next one. Yeah.
Okay.
Yeah. So whatever you have written, I think you'll be able to run through this one, this set of interpreters. So it just compiles there and launches the job in background to Yarn. So Yarn will provide a number of containers which are needed for the, which is asked by the notebook, and your job will be running literally on Yarn. And what you will see is basically the output which comes from the Yarn, and how the progress is being made. So if any errors are there, you can debug through the logs which is here. So theoretically, you don't need to worry about the infra layer. So it is, at this point of time, it is actually showing only Yarn, but same thing for Kubernetes as well. So if you have Kubernetes running in the background, you'll be able to launch everything from here and manage the whole life cycle of your ML development through the particular notebook if you are using that. Yeah, but you may be using different notebooks, right? So if at this point of time you integrate only with Zeppelin, yeah, so that's what.
Thanks.
Yeah.
I think you answered my question. So it's currently you have interpreter for Zeppelin. Do you plan to support Jupyter, for example?
Yeah, that's a great question. So we'll support that because data scientists are like, yeah, we know that. And maybe in the future release, future version, it's in the early age, and we have evolved quickly and rapidly. So many companies has the Jupyter requirement, and we will develop in the maybe 0.3 or
yeah, 0.3 usually it will be.
Will come quickly, yeah. Because we first chose the Zeppelin notebook is because that the data engineer can write Spark job here and do some experiments, write some SQL and training and here. So, but the Jupyter seems weak in this area. So we first support Zeppelin here, and then but Jupyter is very important. We will support it later. Yeah. Thank you.
Okay. Are you planning to solve for online model serving as well?
Yeah, we want to serve it because the whole life cycle without the serving, we think it's necessary to cover the serving part because we'll support Kubernetes in the future, and the Kubernetes has strong service capability, so that's not a difficult thing. We can do that serve. We list the goal here in the beginning. You can see that. Okay.
Yeah, here.
Yeah. So actually, we can manage the model versioning and verify it. So verify a model is also very important. So that's required that we have the ability to manage the model. So if this model is not working, then we quickly fall back to the previous version. So that's it. Yeah. Okay. Please.
Yeah.
Is the
Yeah.
advantage of your solution comparison, for example, for Reddy and working Google solutions?
Oh, Kubeflow.
No.
Cloud ML
Cloud ML, like Google.
Cloud.
and Data Lab.
Yeah, so for that actually, so that is one of the introduction as I mentioned, right? So today's most of the job what you run in an ETL jobs or any type of data engineering jobs is in a Hadoop cluster, maybe in the on-prem. And for those kind of scenarios, actually Submarine is actually the solution there. But if you're running Google, so you're in a vendor lock-in, right? So and you are already running your Hadoop jobs inside the Google itself. Hence the native Google service support for this TensorFlow or all the jobs there, which actually help there when you are in the Google ecosystem. But when you're looking at hybrid environment, right, you have some in on-prem, some in cloud, and most of the customers may be on that kind of scenario. At that point of time is where Submarine adds more value. But in the pure only one cloud scenario, Google definitely will help there. But when you're looking at hybrid cloud with on-prem and on cloud and a private cloud, yes, then all these scenarios, that's where Submarine adds more value. Yeah.
Are there any machine learning workloads that would benefit from running on your cluster?
Oh.
Are not supported on Submarine?
Yeah, great. So Sunil introduced this at the beginning. So you can see that the benefits you can get from the Hadoop cluster. We have the, for example, we have the GPU topology scheduling. If you are using GPU card, we have the topology scheduling algorithm which can perform better than the maybe Kubernetes version. And then it's in the best case, we can get 3x speed. And also for the serving, maybe you can use the FPGA to do the serving fast. So it benefits from the platform. So that's the key thing. Yeah.
So it's always possible to use Submarine and launch it on the cluster.
Yeah.
Yeah.
Yeah. Absolutely.
Yeah.
So one of the topology scheduling, what I mentioned was like when what Sangun actually contributed to the community in Hadoop, basically that if you have more than 2 GPU cores, right,
Yeah.
and some of the cores will be very faster, like maybe core number 1, 4, and 5, maybe very nearby, and it may actually be very fast in terms of sharing all the resources. So the topology scheduling actually look at these linear paths which are actually optimized on and only give those one for the containers, so that your scheduling and the way it runs is will be very faster.
Yeah,
so
and in general, this is the best case for 3x speed up. And in general, we have the 30% performance boost. Yeah. So.
Cool. I think we definitely ran out of time as well. So thanks for listening to us, and please visit the last slide what I mentioned, and
welcome contribution.
Yeah, so we welcome the contribution from all of you if you're interested, and share the use cases by joining the weekly course. Yeah, thank you.
Thank you all.